Hi, I'm Siddhika Kaulagi from UC Davis, and in this video I'll be talking about a proposal to enhance code completion in Pydev. Pydev is a plugin in the Eclipse IDE and it is used to help coders to code in Python using Eclipse. The main motivation behind this work is the success of CACHECA, a plugin which we built previously to enhance code completion in Java. Let us have a look at how CACHECA model works. Eclipse has its own inherent traditional code completion unit, which is called Content Assist. How Content Assist works is that it takes the type information, that is the type of the variable, and then does a syntax and semantical analysis to provide a list of predictions. What CACHECA does is something different. It takes into account two types of analysis. One is the n-gram analysis, and the other one is using the caching model. N-gram analysis basically takes the n previous tokens typed by the user and forms a pattern. This pattern is then analyzed over a huge corpus of Java code, and it is used to find similarities. Why this is very important is that we all know that software is very repetitive, and if we have a pattern and find something very similar which has been done repetitively in a huge code base, it means that we are somewhere closer to finding what the most relevant next token would be. And that is how the predictions are created using n-gram module, each prediction with a useful relevant score, and that's how they are ranked. In the caching model, what happens is it addresses one other issue which the n-gram model kind of overlooks. This is called the locality of the software, or the local context. What it means is that every file, or in specific every user would have some specific variables or constructs in the code, and that forms the local context of that particular file. So every prediction needs to be modified dynamically to support those variables. Supposing instead of a for loop with I have a for loop with size, then my predictions need to be modified in a similar way. And that is what the cache model tries to address. It dynamically changes the predictions from the n-gram model to suit a specific local context, and then a list is generated. And this list is consolidated with Eclipse's Content Assist, the list which that generates, to form a consolidated list. This is done using several heuristics. And we have done a lot of testing, and as a result of that testing, we find that the consolidated list which we get is almost twice as effective as compared to using only Eclipse's Content Assist. Now let's have a look at how all of this really works. Let's go to the Eclipse IDE, and now I'm at a default Content Assist mode. I have not turned on CACHECA. So let's first try a very simple construct, a very commonly used construct, system.out.println. So system.out.println. If you see here, println does not come in any of it. It comes way below. It is not in the top 10 proposals at all. So let's see if we switch to CACHECA, if there is any difference in this proposal list. So how I do that is I go here and I change it to CACHECA sort, and then I turn on CACHECA and turn off the default proposal. And now if you see here, I see println in the top 4. Why this happens is because of both the n-gram and the cache model. So this token, which forms the base for the n tokens, the pattern is then analyzed over a huge corpus, and it is found that it is a very similar and repetitive pattern and is mostly followed by append or println, which is why they come in the top 4. Another reason is that I have also used this construct repetitively in my code, and hence the cache model also ranks this in the top 4. It ranks it quite higher, which is why we get a final better prediction list when we use CACHECA. Here, let's see one more example. I have this code fragment here. I'm basically trying to tokenize a string, and I have used replace all and trim quite repetitively. So let me try it again, and now I'm using CACHECA. So if I see here, I see replace all and trim in the top 10 proposals. If I use only content assist. Going back to content assist and going back to Java proposals. And now if I try to have predictions, I see that replace all and trim are not in the top 10 at all. They are somewhere below. So this shows us that the local context also plays a very important role in giving effective predictions. One more very important result which we identified is CACHECA's support for dynamic typing. So dynamic typing in Java's context means that if we do not have the libraries imported yet, or if we are not sure of the type of the variable yet, in that case, Content Assist does not have much support to give very relevant predictions. Now, I'm right now on Content Assist, the default one, and let's say I have an unknown type T, and if I try to get any prediction, I have no default proposals. But if I switch over to CACHECA, the results are kind of different. So again, I enable CACHECA, I disable the default, and now I get a list of proposals. These are more relevant for me, even though the type of the type of the variable T is not known. This is a very important result, and this forms a base of why we could extend this work to Python as well. Python, as we know, is inherently a dynamically typed language. This means that it does not require the user to give any kind of type information while coding. And given CACHECA's support for dynamic typing, it would be immensely significant to have these kind of predictions given to coders while coding in Python. Pydev also has its own code completion unit, and we tried to test the code completion unit of Pydev to see how significant or how relevant the predictions are. We went about with testing in this manner. We had a code base of Python files. We stripped it of the comments and tokenized all the files. We then gave it as input to the Pydev's code completion unit and tried to recreate these files. Meaning, for every word, we tried to predict the next token and get to see if we are able to recreate files. And this was a sample result which we can see here. This sample output file shows us two major results. One is the actual token which we wanted Pydev to predict and what it actually predicted. The pattern which we observed throughout the code base which we tested was that only the basic keywords like import were predicted with great accuracy. Other keywords like when I want to import a string or when I want to import sys or use a regular expression, the prediction list was not very accurate. Many times it did not even give the keyword in its prediction list. And this is the pattern which we observe throughout the code base. We see support only for basic keywords, but we don't see any dynamic changes according to what the user types, no local history support or no dynamic typing support, and hence the list which is finally generated and given to the user is not very helpful. From the support which we know that CACHECA has for dynamic typing and from the success rate for CACHECA which we see for Java, we are quite positive that we can apply the CACHECA approach to Pydev as well, and we can enhance the code completion module to give better predictions in Python, thus helping a lot of developers code more efficiently in Python. Thank you.